Hello, everyone. My name is Diane Buterak, and I'm Ecology's project lead for the Greenhouse Gas Assessment for Projects, or GAP rulemaking. On behalf of the Department of Ecology, welcome, and thank you for joining us. And welcome to our final webinar for the rule development portion of the GAP rulemaking. I appreciate everyone here taking time during a difficult period to provide input for this important rulemaking. Due to the COVID-19 outbreak, we are holding our meetings online as webinars to protect public health. We will do our best to keep the meeting moving smoothly, and I appreciate your patience. Our goals for the webinars are to provide information so you can learn what we're thinking as we develop the rule and to get your feedback on the presentations and input for drafting the rule. We're here to provide information, our initial thoughts for the GAP rule, to get your feedback, provide a brief summary of what we've heard so far, and to present questions where we would like your input. We will cover the main points from the previous webinars, but not everything. You can always go back and look at those on our webpage where you'll see links to the meeting summaries, the slides, and the video. After the presentation, we will take a short 5-minute break, and then the time will begin for public input and feedback. We'd like to hear what you think the rule should include. As Sadie mentioned, people will have 3 minutes to speak, and if there are no people wishing to speak, we'll take a short break and then check again. We may close the meeting early if everyone has had a chance to speak. Let me introduce the ecology staff who will be helping during this webinar. Brendan McFarland is the Environmental Review and Transportation Section Manager and will provide information on the State Environmental Policy Act, or SEPA. Neil Cottle is our greenhouse gas expert. Bill Drumheller is our expert on climate and energy. And I am Diane Buterak, the GAP Rule Project Manager. Sadie Hinkland will be hosting and will help facilitate the webinar and provide technical assistance. At the June webinar, we provided information on the rule purpose, process, and timeline. We discussed key concepts being used for the rule development. Then at the July webinar, we discussed which projects the GAP rule would apply to. At the August webinar, we provided initial thoughts on the environmental assessment methods, and in October, we provided information on mitigation. Again, videos and slides of these presentations and a meeting summary are available on our GAP rule website. Now we'll talk about the GAP rule purpose and timeline. Ecology has started rulemaking as directed by Governor's Directive 19-18. The purpose of this rulemaking is to create a new rule, Chapter 173-445 of the Washington Administrative Code, Greenhouse Gas Assessment for Projects. We call this the GAP rule. This rulemaking will address analysis and mitigation of greenhouse gas emissions for environmental assessments of industrial and fossil fuel projects. It will provide consistent and comprehensive assessment methods for industrial and fossil fuel projects and provide clarity and transparency to industry, the public, and agencies. On May 1st, 2020, we announced the start of rulemaking and issued the CR 101. From June through November of this year, we are holding 5 public webinars to help get public input on the draft rule. From December through April of 2021, we will prepare the draft rule. It's scheduled to be released in April of 2021 for formal public review and commenting. In rulemaking, we call this the CR 102. As with all ecology rulemakings, we will consider the comments on the CR 102 and use that to prepare the final rule. The final rule is scheduled to be adopted on September 1st of 2021 and would become effective on October 2nd, 2021. In our initial thoughts, the rule will have 3 main parts: an initial screening process to determine applicability, environmental assessment methods, and mitigation. We plan to use existing rules and standards where possible for consistency and to make the process easier. The current phase we are in is called rule development. So we don't have a draft rule written. We are looking for your input and feedback to develop it. Now I'll turn it over to Brendan to talk about SEPA and the GAP rule.
Thank you, Diane. The GAP rule will not change the SEPA rules, Chapter 197.11 WAC. The SEPA rules identify the elements that should be considered in an environmental assessment. Other state and local rules, policies, and guidance are used to assess potential impacts and provide methodologies for the analysis. The GAP rule would be used in this way. If a proposal is not covered by the GAP rule, emissions would still be considered under SEPA on a case-by-case basis. This means that proposals are not automatically exempt from having to consider greenhouse gas emissions if they are not covered by the GAP rule. The methods described in the GAP rule could also be referenced or used by SEPA lead agencies for greenhouse gas emission assessments for proposals not covered by the rule, but this would not be required. This is a simplified diagram of the SEPA review process some of you may be familiar with. The GAP rule can intersect with the SEPA process in a few places as shown by the purple stars. The first two are pre-threshold, meaning that the GAP rule greenhouse gas assessment would be completed prior to a SEPA determination being made. The first star would be if the assessment and mitigation plan are done by the applicant as part of their initial application materials. The second star would be if the SEPA lead agency reviewing materials submitted by the applicant requires an assessment to be done prior to making a threshold determination. The final star shows the GAP rule assessment and mitigation plan being completed after the threshold determination as part of a detailed environmental impact statement process. Now, I will turn it over to Neil Cottle.
Thanks, Brendan. Next, I'll talk about our initial thoughts on when the GAP rule would apply to a project and provide some examples. The rule as we currently envision it would apply to the following types of proposed projects with likely greenhouse gas emissions. The focus of this rule will be on fossil fuel and industrial projects per the governor's directive. Proposed projects include those for a new facility or for changes to an existing facility which require environmental review. An initial screening process would be used to determine if the GAP rule applies to a project or not, and we will discuss that later in the webinar. The rule would be used by any lead agency under SEPA. That could be the Department of Ecology, another state agency, a local government, or others as designated in the SEPA rule. It can also be used by project applicants in preparing their documents for the environmental review process. By greenhouse gases, we mean the GHGs defined by the Washington legislature, and the official list of GHGs is available in WAC 173-441-040. The most common GHGs are shown here. The list is used as the definition of greenhouse gas for a variety of Washington programs. We intend to use that established list in the GAP rule as well. This consistency means that all of Washington's greenhouse gas reporting programs are compatible with each other. Also, referencing the existing list results in the fastest possible updating of all programs when new information is ready. The rule would not apply to existing facility operations which are already permitted. The rule would also not apply to projects currently going through or those which have completed a SEPA environmental review process. Under our current thinking, the rule would not apply to programmatic reviews or plans like a comprehensive plan update, highway, road, or passenger rail projects, or housing projects. Programmatic reviews or plans are usually conceptual, not at a project design level. For example, a comprehensive plan is a generalized land use policy statement of a county or a city's vision for the future and includes goal policies to achieve the vision. So these plans would not lend themselves to the type of quantitative analysis that would be done for a specific project. This approach meets the governor's directive to develop a rule for assessing GHG emissions for industrial and fossil fuel projects. For projects that are not covered by the GAP rule, greenhouse gas emissions would still require consideration under SEPA on a case-by-case basis. An initial screening process would be used to determine if the GAP rule applies to a specific fossil fuel or industrial project. In our current thinking, the screening process includes looking at 3 types of emissions. In each case, we'd be evaluating emissions related to the project. If the project is a new facility, all emissions are included. If the project is a modification, then only the change in emissions counts toward the screening process. The 3 types of emissions are facility on-site emissions, emissions related to inputs or feedstocks used by the project, and emissions related to outputs or products made by the project. If the screening process identifies a project as being applicable, then the GAP rule must be used. The first step is to evaluate a project's on-site emissions. This mainly applies to industrial sources, so we use our existing greenhouse gas reporting protocols as they're designed for industrial facilities and processes. Washington's Greenhouse Gas Reporting Program, WAC 173-441, uses the same methods established in EPA's Greenhouse Gas Reporting Program, 40 CFR Part 98. Emissions from combustion of biogenic materials would be included in this screening process. The GHG reporting program also includes reporting of biogenic CO2. Normally, facilities report their actual emissions, but that is not possible here since we are evaluating new facilities or modifications that have not yet happened. Instead, we would rely on potential to emit, or PTE. For example, instead of calculating natural gas combustion based on billing records, the screening would use a conservative estimate, like proposed permit limits or boiler rating instead. The project's emissions are then compared to a 10,000 metric ton carbon dioxide equivalent per year threshold. If over the threshold, then the project is subject to the GAP rule. For context on the 10,000 metric ton threshold, about 150 facilities in Washington are currently over the threshold. This map shows examples of where they are located, and the list describes the types of facilities included in the program. Many exceed the threshold due to combustion of large amounts of fossil fuels. Others have some or all of their emissions come from various chemical or physical processes on site, such as mineral off-gassing at cement or glass plants, and leaks of potent GHGs from electronics manufacturers. Now we will look at an example using a theoretical modification to an existing facility. A university is expanding their main campus, including adding a boiler. Currently, they have natural gas units rated at 500 MMBTU per hour that use 10 million therms of gas per year, which equates to about 53,000 metric tons CO2e per year. These existing emissions do not count toward the applicability screening. Their proposed project will add a natural gas boiler rated at 25 MMBTU per hour. Assuming 8,760 hours of operation per year and emissions factors from the reporting program, we can calculate potential emissions of about 11,620 metric tons of carbon dioxide per year. Therefore, the project exceeds the applicability threshold, so there's no need to complete further calculations, for example, calculating emissions for other GHGs like methane and nitrous oxide. The GAP rule would apply. Not all projects will have facility emissions greater than 10,000 metric tons CO2e. Those projects will also be evaluated based on their inputs and outputs. Inputs are materials used by the project, like natural gas used to make fertilizer at a chemical plant. Outputs are materials made by the project, like gasoline from a refinery. If the on-site emissions are less than 10,000 metric tons, then the next step is to identify all the inputs and outputs associated with the project. The GAP rule would include a list of inputs and outputs subject to the screening process, such as electricity and fossil fuels, ranging from natural gas to petroleum products to coal. The fossil fuel list will be similar to the list in 40 CFR Part 98. Calculation methods will also be supplied for fossil fuels not on the list. The list would also identify the amount of each input or output that exceeds the screening criteria. The amount will be approximately equivalent to 10,000 metric tons CO2e. Since the facility process, similar to the facility process, this will use potential to emit amounts such as permit limits or equipment capacity. If a single input or output or combination of the inputs or outputs exceeds 10,000 metric tons CO2e, the project is subject to the GAP rule. Now we will look at an example of a new facility with no existing emissions. In this case, a new petroleum refinery. Refineries are large sources, so facility emissions would certainly be over 10,000 metric tons CO2e. This alone would meet applicability, but for this example, we will continue to look at inputs and outputs. The refinery would use several applicable inputs or feedstocks, including crude oil, natural gas, and electricity. Each of those will likely exceed the screening levels listed in the rule. Therefore, the project would meet applicability standards. Again, we would normally stop, but in this case, we'll continue to the next step as an example. The refinery would also make several products or outputs, including gasoline, diesel, and petroleum coke. Once again, each of those will likely exceed the screening levels listed in the rule. Therefore, the project would meet applicability standards. The Because each of these are over the thresholds listed in the table, the project meets applicability based on any of those checked emission sources. The gap rule applies. We received input and feedback on our initial thoughts for the applicability standards. We are sharing areas where there is agreement and areas where there is no consensus. It is not surprising that we've received a wide range of input and views. For applicability, there were areas where there was no consensus. Some said the rule should apply to fossil fuels and industrial projects. Others said it should apply to all projects. Some said it should exempt linear projects like pipelines and electric transmission lines. We heard differences in perspective on the types of emissions the screening process should consider. Some want only direct or facility emissions to apply. Others want inputs and outputs to be included. And there were many different views on the applicability threshold. As we have presented, our initial thoughts are to use 10,000 metric tons CO2e per year, which aligns with the GHG reporting rule. Some supported this threshold, but others wanted the threshold to be zero, and others wanted it to be higher at 25 or 75,000 metric tons CO2e per year. We received some questions where we wanted to provide clarification. What are examples of industrial projects? The emissions would determine which projects need to follow the gap rule. The GHG reporting data shows projects from multiple sectors that would likely be included, such as large boilers, chemical producers, and general manufacturing. Would facility emissions be combined with inputs and outputs for applicability? Under our initial thoughts, they would be estimated separately. Would all SEPA lead agencies use this rule or just ecology? The gap rule would be used by all SEPA lead agencies for applicable projects. Can the gap rule be used for projects that are not applicable? Yes, possibly. The lead agency could use the rule as an example or for guidance. Now I'll turn it over to Bill Drumheller.
Hi, I'm Bill Drumheller, the Climate and Energy Specialist here at Ecology. And I'm going to summarize where we are in terms of the environmental assessment part of the rule to meet the governor's directive. So the environmental assessment part of the rule will consist of three major parts. There's the on-site emissions focused on the project facility or the core project infrastructure and its primary geographic location. The energy analysis, that would look at the direct or indirect effects on energy supply, output, load, or other energy impacts associated with the project. And the last would be the life cycle analysis focused on the full life cycle or the cradle to grave greenhouse gas emissions associated with the project. So each of these three parts will be discussed separately in the slides that follow. So the governor's directive tasked Ecology to ensure, ensure a comprehensive assessment and quantification of direct and indirect greenhouse gas emissions resulting from the project. So we propose using existing methods to assess the direct and indirect emissions associated with the project facility, recognizing that the rule would apply to projects where there may not be a typical facility like linear infrastructure projects, pipelines, electricity transmission, the like. For direct emissions, we are proposing to use approaches from the existing Washington State Greenhouse Gas Reporting Program. These are based on EPA's similar federal greenhouse gas reporting program methods. In addition, some EPA methods for calculating emissions have been developed already, but they were exempted from use in the federal reporting program for various reasons. But those methodologies are still useful. So in some cases, we are also proposing to use these federal reporting program methods when those are in fact useful to include. The rule will also provide direction regarding the on-site use of electricity and other indirect operational emissions. And for construction and decommissioning emissions, we're proposing to use some of the best practices out there that have been developed in especially recent SEPA and NEPA analyses. So the governor's directive also required a assessment of any induced load or growth in fuel or energy consumption or electricity generation from the project. So the energy analysis part of the rule would fulfill this part of the mandate from the governor. So a project that would increase flow or capacity of energy supply would have to analyze the downstream potential impacts, regardless of whether those impacts increase energy or the commodity flow is part of the project itself. So, for example, a project may increase the capacity to move energy, but the project may not propose to utilize that added capacity as part of the project. So also a project that creates a new line or route of energy supply or a new type or form of supply would have to address the implications of those changes if greenhouse gas emissions may be affected. So, for example, changing an energy source from a gaseous state to a liquid state may change the way that that embodied energy can be moved or stored in world markets. So that would something that would have to be addressed in the energy analysis. The energy analysis could also be used to understand potential geographic leakage effects or market effects. This could help answer questions like, is this project likely to result in moving greenhouse gas emissions out of the state, out of Washington? There are also just a wide range of possible economic market effects. So, if an energy supply is increasing, shifting, transforming, or otherwise changing, what are the market implications of that shift in energy supply? So for over 2 decades now, greenhouse gas life cycle analyses have relied on a common approach, or the vast majority of them at least, developed by the International Organization for Standardization, or known as the ISO for short. The ISO is a universally recognized standards body. And as part of their standards that they've put into the world, they've put in place a series of standards called the 14040 series, the 1440 series. It establishes a conceptual framework and guidance as to how to conduct a life cycle assessment. So these are highly reputable, well-established international standards. We're proposing that the rule use these ISO standards as a foundational framework for the life cycle assessment. And specifically, we're proposing using the ISO 14040 standard, which is called the Environmental Management Life Cycle Assessment Principles and Framework Standard, and also the ISO 14044 standard. That one's called the Environment Management Life Cycle Assessment Requirements and Guidelines standard. So the ISO 14040 standard establishes the principles and framework for how a life cycle assessment should be done, and it's focused more on concepts than sort of tangible steps, steps that one should take. The ISO 14044 standard is the more detailed standard, and that provides requirements and guidelines for a life cycle assessment. So it includes requirements for collecting, calculating, validating data, and that one's more of a sort of a step-by-step approach, a little more tangible, less high level. So taken together, the two standards, the 14040 and the 14044 standards, work together to create this holistic protocol for conducting a life cycle analysis. But to be clear, the GAP rule will need additional detail to ensure a consistent implementation approach using the standards. And that's something we've asked for in previous webinars and continue to ask for comment and input on where the GAP rule language should include more specifics, or perhaps where the language in the standards or just the rule in general should be more flexible and maybe not have sort of more prescriptive language associated with it. So next, I want to talk about one of the more complex aspects of the rule. So many of the projects covered by the GAP rule would produce or potentially move products that compete in the global marketplace. In order to understand these competitive dynamics, it may require an economic analysis tied in with other modeling efforts. So, for example, a model that addresses energy supply, or, using energy pricing models. And, the key point here, I think, is that different emission perspectives are possible in this part of the assessment. just to reiterate, we've talked about this before, but it's really important. When we talk about gross emissions associated with the project, we mean those emissions associated only with the project itself. That's meaning the emissions that result from a typical life cycle assessment, such as the upstream emissions, the downstream emissions, and the on-site emissions associated with that project. And then when we talk about net emissions, we mean project emissions, so that the gross emissions we just talked about, relative to alternative market scenarios for a product. So for example, a scenario where the project is built and competes in the global marketplace, but comparing that to a situation where the project is not built and perhaps alternative economic scenarios play out based on market conditions over time. So perhaps a product is manufactured in a different way or with different inputs, and comparing the project that we're analyzing with those alternative futures. So, the bottom line though is the net approach looks at the difference in emissions between scenarios, not just at the emissions of the project itself in isolation. So, it's important to note for this type of net analysis, there are significant hurdles and complications. Acquiring the relevant data can be challenging, very challenging, especially from foreign sources. If we're talking about a product that's competing on the global marketplace, it likely involves supply and demand projections and other general economic projections, which often have a high level of uncertainty and can be time and resource intensive, and also, frankly, expensive. So in the same way that Neil just covered about the discussion on applicability, we want to sort of highlight some of the feedback and input we've received on some of the concepts we just went over when we presented the previous webinars, in combination with other stakeholder discussions that we've heard and just some of the general feedback we've gotten. Basically, there are some areas of consensus. We've heard the assessment should use, scientific data and methods, sort of best available science, should rely on credible sources of data, and, not surprisingly, needs to be useful for estimating emissions, comparing emissions, and needs to have a solid analytical basis, greenhouse gas emissions basis. But there were many key areas where there have been differences in views. So input on the boundaries, the emission types to be assessed very widely. Some really only want to look at on-site or facility emissions. Other want for the assessment part to have a much larger range. Looking at just a much broader range of inputs and outputs into the life cycle analysis. Some on the issue of what kind of geography to look at. Some folks really only want to look at the facility. Others really want to keep this to sort of a Washington state perspective, just looking at the lands and territorial waters of Washington state. And others want more of a truly global analysis with no real geographic boundaries. Also, as we just discussed, the issue of the market analysis has been subject to a lot of opinions one way or another. Some want a market analysis to be part of this assessment. Others do not. We certainly heard that some consider the displacement analysis that can be part of a net emissions analysis to be speculative. But others believe it's important that type of analysis and this kind of displacement theory be part of the assessment analysis. We've also heard a wide array of views on the threshold for significance. So and not surprisingly, those viewpoints vary widely. Some propose the lead agency should determine this. Others believe that it should be based on the future greenhouse gas reduction goals and how a project might compare to those. And another common opinion we've heard is that the threshold should be 0. That essentially any emissions would be a basis for significance. And there's also been, no consensus on whether the issue of leakage, geographic leakage, that is to say, when greenhouse gas emissions end up leaving the state of Washington as part of a project should be part of the analysis. And finally, certainly no consensus again on this overall, this important overall determination as to whether project emissions should be assessed on a gross basis or a net basis. And also to point out, we've also heard from a number of stakeholders that they want essentially what has been called a climate test, basically as part of the assessment. Some part of that should include, in the opinion of those who want this climate test, to identify or analyze whether the project is consistent with a low carbon future. That is to say, some scenario which involves a significant reduction in greenhouse gas emissions globally. So that's another thing we've heard in addition to the above. So also want to point out we've received some questions where we want to provide clarification. So would a project changing or modifying an existing facility need to look at the inputs and outputs to that facility? And the answer here is certainly yes. Obviously a key part of the life cycle, given again the governor's directive to include a life cycle assessment. That life cycle includes both upstream and downstream aspects, and so that the inputs and outputs into the project are a critical part of the life cycle assessment. And another question we've heard is would the assessment allow for different types of methodologies to be used, and methods, and certainly there are many methodologies and analytical tools, specific models, life cycle models, even for certain types of that would be applicable to certain types of projects. And we're definitely going to be, the rule will definitely have the flexibility to allow sort of the appropriate tools and methodologies and models relevant to the project to be used. So with that, I'm going to turn this back to Diane to continue, and thank you.
Thank you, Bill. Now I'll provide our initial thoughts on mitigation. So SEPA requires consideration of mitigation to address significant impacts. The GAP rule does not change the underlying SEPA process. In our initial thoughts, the GAP rule environmental assessment would identify greenhouse gas emissions from the project to determine potential impacts. The rule would require an applicant to develop a mitigation plan to address the greenhouse gas emissions of a project. Under SEPA, mitigation may be required through the decision or permit processes, or it could be voluntary. Our initial thoughts that under the GAP rule, a project applicant would be required to develop a mitigation plan. The rule would identify what elements need to be included in this plan. It would identify the types of emissions to be covered by the mitigation plan, how to determine if a project type is eligible as mitigation, and establish criteria that mitigation projects must meet. And finally, it is envisioned that the rule would provide processes or context for prioritizing where mitigation projects should be located. So we'll talk about that next. So while all of the details of the environmental assessment part of the GAP rule have yet to be finalized, as we were just discussing, it's expected that the assessment would include several types of greenhouse gas emissions for a project, such as on-site emissions, in-state emissions, be that on-site, upstream, or downstream, and then out-of-state emissions, upstream or downstream. Mitigation could be used to address one of these emission types or a combination of these. There are two primary pathways in the greenhouse gas world to reduce or remove greenhouse gas emissions. The GAP rule would allow for mitigation of greenhouse gas emissions through both of these pathways. The first one is where an applicant could pay for a project on their own or through a third party. This is called direct funding of projects. Another way is to buy offsets through established carbon markets. Offsets would be required to meet quality standards established through internationally recognized registries. The rule would include a number of criteria that mitigation projects must meet. These include real, meaning a project meets all of the applicable criteria; permanent, meaning emission reductions are not reversible. That is, once the emission reduction occurs, you can't go back in time and make it not occur. But in the case of sequestration projects, those do have the potential to be reversible, so there would need to be guidance under what conditions, if any, the carbon dioxide that is stored or sequestered would be considered equivalent to an emissions reduction. Enforceable, which means a guarantee an emission reduction or removal will happen if it's promised. Verifiable, which would show the benefits of the mitigation project can be measured, quantified, and tracked over time. And additional, basically, if a mitigation project is going to happen anyway, then that wouldn't be included. The location of mitigation projects could be anywhere. The rule would provide context for where mitigation projects would be prioritized. For example, projects could be prioritized for communities disproportionately affected by climate change, communities with a concentration of low-income populations, minorities and communities of color, and tribal communities. Also, mitigation projects could be prioritized geographically, with local projects being the first priority and then expanding to regional and then national and international projects. As we've done before, we're going to provide some areas where we've heard feedback. For mitigation, there were some areas of agreement. Everyone seems to agree that facility on-site emissions should be mitigated and that mitigation should support social and environmental equity and encourage innovative projects. But there were several areas where the feedback varied quite a bit. Some think mitigation should reduce emissions to zero. Some suggest the mitigation be below zero. Others suggest mitigating the emissions to 10,000 metric tons, and others that the mitigation should be proportional using state greenhouse gas reduction targets. We heard from some saying the upstream and downstream emissions should be included for mitigation. Others said they should not be included. And there were varied opinions on if or how mitigation should include things such as best available control technology, energy efficiencies, new technologies, or responsible growth allowance. The next three slides include questions we've asked during our previous webinars and sent out to the listserv. We haven't received many responses, so we'd like to provide them again and ask you to provide any input or feedback by December 15th. It does look like we have people who have been on the previous webinars, so I'm not going to read through all of these. I'll put them on the screen, and then again, you can look at them on our webpage later, and we'll also send them out to the listserv after this. So there'll be a few ways to go back and look at it. We don't expect you to read them all right now. These are some of the things that we've asked for, and we want you to go ahead and think about these, and we really would like your feedback and input. And Sadie's adding some links in the chat that you can get to those straight away as well. So here are questions. We have two slides with questions about environmental assessment. I'll just give you a second to take a quick look. These cover many of the topics that Bill brought up when he was making his, when we stopped presenting the slides on environmental assessment. Here's the second slide, also with questions about environmental assessment. And then the last slide are questions that we have about mitigation, which are some of the things that I just spoke about. So again, I'm not expecting you to have read through all of those, but you can use the link, or you can go to our webpage later and take a look at those. And again, we'll send them out to the listserv. Again, you've got them already, but we'll send them out again. And we would like to get any input or feedback from you by December 15th if possible.